For nearly a century, highway agencies and paving contractors have been constructing roads of hot mix asphalt, and with good reason. Asphalt pavements are smooth riding and long-lasting. Today, there's a new set of tools and techniques called the super pave system that allows us to design even more durable asphalt pavements. Super pave, which stands for Superior Performing Asphalt Pavements, is the mix design system for the next century. The super pave system has two key components: performance-based asphalt binder specification and volumetric mix design and analysis. It also uses an improved method of laboratory compaction that reflects field conditions. Pavements take quite a beating. Not only are they subject to ever-increasing traffic loads and volumes, but they also must serve in a wide range of conditions. The super pave system incorporates a new binder specification that classifies asphalt binders into performance grades based on a range of climates and pavement temperatures. The specification sets certain physical properties that all binders must meet, but the temperature at which those properties must be attained is determined by the specific climatic conditions at the paving location. Super pave binders are classified by PG for performance-graded ratings. The rating contains two numbers indicating high and low pavement temperatures. For example, a PG 64-22 binder used in a super pave mix is expected to be resistant to cracks and ruts at pavement temperatures as high as 64 degrees Celsius and as low as -22 degrees Celsius. To select a super pave binder, you first determine the average 7-day maximum pavement temperature and the minimum pavement design temperature for a particular job site. To make this task easier, a weather database with more than 6,000 weather stations is included in the super pave system. For pavements in extreme climatic conditions, some asphalt cements may have to be modified, but modified or not, a PG binder will have the required properties to perform as expected during the pavement's life. This is what is meant by a performance-based specification. Asphalt refiners and suppliers are converting to PG-rated binders. The conversions are being done on a regional basis in coordination with highway agencies' shift to the super pave binder specification. Hot mix asphalt producers should be able to buy PG binder from the same supplier they currently use. Testing binders for conformance with the super pave specification requires several new pieces of laboratory equipment, but the PG-rated binder requires no changes to standard methods of handling, storing, and transporting binders. Super pave mixes are based on volumetric properties. The characteristics of the aggregate and the volumetric properties of the mix, such as air voids and voids in the mineral aggregate, form the basis for selecting aggregate gradation and asphalt binder content. The super pave system bases aggregate selection on consensus properties that apply equally at all locations. They include coarse aggregate angularity, fine aggregate angularity, flat and elongated particles, and clay content. In addition, each highway agency determines source properties in light of local or source conditions. Source properties include toughness, soundness, and deleterious materials. These tests for measuring aggregate properties are not new. Many highway agencies are already using the tests in conventional mix design. Switching to the super pave system will therefore require little or no additional training in aggregate selection. To improve the properties of the asphalt mix and the performance of the pavement, the super pave system provides a means for determining the optimum aggregate structure or gradation. The aggregate gradation process is a refinement of an approach already in use by many highway agencies. Gradations are defined using the Federal Highway Administration's 0.45 power chart. The chart can be used to show total particle size distribution for an aggregate blend. The chart is also useful for understanding how aggregate particles fit together. The maximum density line is plotted from the origin through the maximum aggregate size. The SuperPave system adds two features to the 0.45 power chart, namely control points and a restricted zone. The control points serve as boundaries for the outer ranges of key sieves. 3 sets of control points are plotted, one for the nominal maximum sieve, one for an intermediate sieve, and one for the smallest sieve. Aggregate gradations must stay within the control points. The so-called restricted zone is actually a warning zone, providing a guideline for mix designers. Gradations falling in the restricted zone may have too much rounded natural sand. Mixes constructed using such gradations often experience compaction problems during construction and can be prone to rutting. For best results, mix designers should choose a gradation that falls between the control points and avoids the restricted zone. The next step in designing a SuperPave mix is determining the optimum aggregate structure. The aggregate sources are evaluated to develop 3 or more trial blends that meet the gradation requirements. Aggregate properties for the blends are then calculated. The appropriate PG asphalt binder is then mixed with the aggregate, and the mix is aged in an oven to simulate the aging that occurs during the construction process. The trial blends are evaluated by compacting the specimens and determining their volumetric properties. The SuperPave system uses a new method of laboratory compaction, the SuperPave Gyratory Compactor. The SuperPave Gyratory Compactor is quiet and easy to use. It more accurately reflects field compaction, and research has shown test results to be significantly more reproducible. The asphalt mixture is loaded into a mold 150 millimeters in diameter. A ram loading system maintains a constant pressure on the specimen. The mold is tilted at a slight angle and rotates while the load is being applied. The number of rotations or gyrations required for each specimen is dependent on the highest air temperature and the amount of traffic expected at the paving location. During the compaction process, the height of the specimen is continually monitored, allowing the bulk-specific gravity of the specimen to be continuously calculated. Upon completion of compaction, the specimen is removed from the mold. The volumetric properties of the mixture are calculated, and the data are analyzed to determine which aggregate blend provides the optimum aggregate structure. Volumetric analysis is an integral part of most mix design procedures and is at the core of the SuperPave system. Extensive studies have shown that volumetric properties are directly related to performance. Volumetric properties include voids in the mineral aggregate, or VMA, voids filled with asphalt, or VFA, and air voids. Controlling the volumetric properties in the field will ensure that the pavement will perform as expected. The optimum asphalt binder content is then determined for the selected aggregate structure. Samples that have been prepared using different asphalt binder contents are compacted using the gyratory compactor, and volumetric properties are determined. The asphalt binder content that results in 4% air voids is then selected. The SuperPave Gyratory Compactor can also be used for quality assurance at the construction site by determining whether the plant-produced mix meets the SuperPave volumetric requirements. As we've seen, the SuperPave volumetric mix design process involves a new asphalt binder grading system, consensus-based aggregate properties, and a new method of compaction. The mix design process consists of 3 main steps. Select the aggregates, binders, and possibly modifiers to be used in the mix. Select the design aggregate structure. Select the design asphalt binder content. Nationwide use of the SuperPave binder specification is expected by 1997. The Asphalt Technical Working Group, which provides guidance and direction to the nationwide SuperPave implementation program, has set a target date of 2000 for adoption of the SuperPave mix design procedures. The actual schedule of implementation is, however, up to each state highway agency. Many highway agencies are already designing and specifying super paved pavements. The Federal Highway Administration is coordinating the transition to super pave as part of its overall program to implement the results of the Strategic Highway Research Program. It includes training and technical assistance in super pave binder selection and volumetric mix design procedures. Training and technical assistance are also available from a number of other organizations, including the Regional Asphalt User-Producer Groups, the Regional Superpave Centers, state and local highway agencies, National Center for Asphalt Technology, industry associations, including the National Asphalt Pavement Association and the Asphalt Institute, and universities. Superpave is the next generation of hot mix asphalt pavement technology. It provides a new set of tools for designing smooth-riding, longer-lasting asphalt pavements. This advanced technology is ready to be put to use today. Superpave, the mix design system for the next century.